In the heart of a dying star, where temperatures forge the heaviest elements known to the universe, lies a secret that James Webb has just revealed. An iron barrier, floating in cosmic fire, holds the key to understanding how death becomes the architect of new worlds. This is not just an observation. This is a revolution. Imagine a star's funeral pyre, but not just a pyre, a grandiose forge of cosmic scale, where in the final moments of life, the luminary creates something amazing, something incredible, massive structures of pure iron that will drift through space for billions of years. In January 2026, the James Webb Space Telescope turned its unseeing eye toward the constellation Lyra, where at a distance of 2,300 light-years from Earth hangs one of the most recognizable and beautiful structures in the night sky, the Ring Nebula. And what it saw at its very heart forced astronomers to reconsider many concepts about stellar death. The Ring Nebula is not just a pretty picture for desktop wallpaper. It is a living monument to the death of a star similar to our Sun. About 5,000 years ago, when the first great civilizations were just emerging on Earth, a star in the constellation Lyra exhausted its hydrogen reserves. Its core began to compress, outer shells expanded, turning the luminary into a red giant. And then something happened that will someday occur with our Sun as well. The star shed its outer layers into surrounding space, creating an expanding cloud of gas, glowing under the influence of ultraviolet radiation from the dying core. Thus was born a planetary nebula that received the name Ring. Astronomers have studied this nebula for centuries. William Herschel observed it back in the 17th century. The Hubble telescope captured its detailed structure, but James Webb saw what was hidden from all previous instruments. In the infrared range, through the veil of expanding gaseous shells, the telescope discerned the central part of the nebula there, where a thermonuclear furnace once raged, and it discovered a structure of almost pure iron, extending for billions of kilometers. Iron, element number 26 in the periodic table. The foundation of our civilization, the blood of our planet, and in a literal sense, the blood of each of us, iron atoms in hemoglobin, carry oxygen through our veins. But where does iron come from in a dying sun-like star? After all, classical astrophysics tells us that such stars cannot synthesize elements heavier than carbon and oxygen in their depths. To create iron requires much more massive stars, giants tens of times heavier than the Sun, capable of initiating carbon, neon, oxygen, and silicon burning. For iron, temperatures of billions of degrees and pressures capable of crushing atomic nuclei are needed. Let us take a virtual journey to this cosmic barrier. We depart from Earth at the speed of light. We flash past Neptune's orbit in a matter of hours, leave the solar system, leaving behind the Kuiper Belt and the distant Oort cloud. Years turn into decades, centuries, millennia of light travel. Finally, ahead appears a faint glow. The Ring Nebula begins to manifest not as a point, but as a structure. Even closer, and we see its true form, not a ring at all, but a toroidal shell, an expanding donut of glowing gas. We see it edge on, which is why it appears as a ring. In reality, it is a three-dimensional structure about 1 light-year in diameter. We plunge deeper, pass through the outer layers of the nebula. Here the temperature reaches 10,000 degrees Celsius. The gas glows in all colors of the rainbow, the red glow of hydrogen, green of oxygen, blue of helium. The density of matter is negligible, only a few thousand atoms per cubic centimeter, which is trillions of times more rarefied than Earth's atmosphere. But the volume is so enormous that the total mass of ejected matter constitutes about 20% of the Sun's mass. All this material moves from the center at a speed of about 20 kilometers per second, expanding the nebula. And now we approach the center. Here, in the very heart of the nebula, lies what remains of the star, a white dwarf, about the size of Earth, but with a mass of 6/10 the mass of the Sun. Its surface is heated to 120,000 degrees Celsius, which is 20 times hotter than the surface of our luminary. It is this dead stellar stub that illuminates the entire nebula with its hard, ultraviolet radiation, making the gas shine. The white dwarf will cool for billions of years, gradually transforming into a black dwarf, a cold crystal of carbon and oxygen. But around the white dwarf, there where until recently was the boundary between the star's core and shell, James Webb discovered something astonishing: a structure of iron and nickel, forming an irregular ring or disk several billion kilometers in diameter. Spectral analysis showed this is indeed metallic iron, with admixtures of nickel, cobalt, and other heavy elements. The mass of this structure is estimated at millions of billions of tons. Where did so much iron come from here? The answer lies not in the processes inside this star itself, but in its history. The star that created the Ring Nebula was not born from the primordial hydrogen and helium of the early universe. It arose from a cloud of gas and dust that already contained heavy elements, the legacy of previous generations of stars. Somewhere in this region of the galaxy, long before the birth of the ring star, a massive star lived and died, possibly exploding as a supernova. It was in that explosion, during a few seconds of thermonuclear madness, that tons of iron, silicon, magnesium, sulfur, and other elements were synthesized. These elements scattered through space, mixed with interstellar gas, and from this enriched material 5 billion years ago, a new star began to form. During the collapse of the protostellar cloud, heavier elements, including iron, tended to concentrate closer to the center, forming zones of increased metallicity. When the star ignited, these zones remained in its depths. For billions of years, the star lived a quiet life, burning hydrogen in its core. But when the red giant phase arrived, convective processes began to mix the star's matter, raising deep material to the surface. And when the star shed its shells, the iron that had accumulated in the transition zone between core and shell remained hanging in space, forming the very structure that James Webb saw. This discovery fundamentally changes our understanding of the galaxy's chemical evolution. Previously, it was believed that planetary nebulae enrich the interstellar medium mainly with carbon, nitrogen, and oxygen. Now we see that they can eject significant quantities of previously accumulated heavy elements, redistributing them in space. This means that the iron barrier in the center of the Ring Nebula is not an anomaly, but a pattern. Dying stars not only return processed matter to space, they become a kind of sorting stations where heavy elements are separated and concentrated. What will happen to this iron next? Over time, the structure will disperse, mix with the expanding nebula. In hundreds of thousands of years, the nebula will dissolve into interstellar space, enriching it with carbon, oxygen, nitrogen, and, as we now know, iron. This material will become building material for new stars and planets. Perhaps in billions of years from this iron-enriched gas, a new planetary system will be born. And on one of the rocky planets of this system, iron atoms that once belonged to the ring star will enter the composition of the planetary core, create a magnetic field, protect the surface from cosmic radiation, allow an atmosphere to arise, oceans, life. Our own solar system is direct proof of this cycle. Every iron atom in Earth's core, every atom in your body was created in the depths of an ancient star that exploded long before the sun's birth. We are made of stardust. This is not a poetic metaphor, but a literal scientific fact. The discovery of the iron barrier in the Ring Nebula is yet another confirmation of how closely life and death are connected in the universe. The death of one star creates conditions for the birth of others. Destruction becomes creation. The end transforms into the beginning. James Webb continues to study the Ring Nebula and other planetary nebulae, revealing ever new details of their chemical composition and structure. Each such observation brings us closer to understanding the complete picture of stellar evolution and how the universe creates the diversity of chemical elements necessary for the existence of planets and life. Perhaps in the coming years, we will discover iron structures in other nebulae as well, understand the patterns of their formation, learn to predict which stars upon death will leave behind such cosmic forges. This journey to the iron barrier in the heart of the Ring Nebula shows us how amazing and complex the universe is. Each new discovery gives birth to dozens of new questions. How exactly do these iron structures form? How widespread are they? What role do they play in enriching the galaxy with heavy elements? And most importantly, how do these processes affect the possibility of life arising in other worlds? Thank you for embarking on this cosmic journey with us. If you enjoyed this video, please like it. Write in the comments what space topic interests you most. You can support our channel and help create even more quality content through Patreon link in the description below the video. Subscribe to our Telegram channel, where we publish the latest news in astronomy and space exploration. Stay with us, and until we meet again in the universe.